Welcome to Study Loop.
Okay, this is chapter 11, section problem 68. And the question is, how much ice in grams would have to melt to lower the temperature of 352 milliliters of water from 25 degrees Celsius to 5 degrees Celsius? And we can assume a density of water of 1 gram per milliliter. And the whole idea here is that the amount of energy released from the decrease in temperature by the water has to be equal and opposite to the amount of energy absorbed by the ice melting. So that's essentially Q is equal to, Q is equal to Q. And the only other equation really that we need here is that Q is equal to MCAT. So the heat is going to be equal to the mass times the specific heat times the delta T. And we need two constants here, the specific heat of the liquid water, which is 4.184 joules per gram per degree Celsius, and the heat of fusion of the ice, which is 334 joules per gram. You might also, be able to look this up as 6.02 kilojoules per mole, but since we're working in grams here, we can just stick with that one. So our starting place here is the volume of liquid water, so 325 milliliters of water times the density, 1 gram per milliliter, and then times the specific heat, which is 4.184 joules per gram per degree Celsius, times that delta T. And delta T is always T2 minus T1, so 5 minus 25. So that'll give us minus 20. And if you plug that into your calculator, you'll get minus 27,196 joules. And that's the amount of energy that it needs to release into the solution. And we can use that as our starting place for the amount of energy that we need to obtain or be absorbed by the ice. So we can see here, if you arrange this, that we're actually going to have to divide by that delta H of fusion, which is why you always want to write these units out like this. So if we take 27,196 joules and divide it by 334 joules per grams of ice, you should be able to get 81.4 grams of ice required in order to obtain that temperature change. Anyway, that's how you do this question, and good luck studying, everybody.